Hello everyone, my name is Chris Edwards and today we're going to write a SQL query. Our problem today involves figuring out whether all values from one set of data exist in another set of data. I've seen this kind of problem pop up every now and again in my professional work, and I think it is useful to know how to approach it. A fastidious home cook maintains a simple database table, kitchen ingredients, containing a list of the ingredients that they currently have on hand in their kitchen. They also maintain a separate table, recipes, that stores the recipes that the cook knows, along with the recipe's required ingredients. We need to write a SQL query to help this cook figure out which recipes they can make using only the ingredients that they have in the kitchen right now. The query should return the recipe names and full lists of ingredients for all recipes for which the cook currently has all required ingredients. And just a note here, we're not concerned with the amounts of ingredients needed for each recipe, just whether each ingredient is in the kitchen or not. This home cook always buys ingredients in bulk from their favorite wholesale bargain store, and if they have any of an ingredient, they tend to have a whole lot of it, so quantity is not a concern. We have our expected results here, and I just want to take a moment to explain these a little more detail. You see here in the recipes table, omelets require butter, cheese, egg, and salt. Quiches require butter, cheese, egg, frozen pie crust, salt, and spinach. If we look over at our kitchen ingredients, you see we indeed have all of the necessary ingredients for both of these recipes. However, if we look back at the recipes, you'll see chocolate chip cookies requires some stuff we have, like butter, egg, salt, etc., but it also requires chocolate chips and flour, neither of which are currently in our kitchen. So unfortunately, we can't make chocolate chip cookies, and it is not included as a recipe in our expected output. All right, well, that is all the setup for today. If you want to have a crack at solving this problem yourself, there are links in the video description to this full problem statement and instructions on how to replicate this coding environment on your local machine. Feel free to pause the video now and come back later for a solution walkthrough coming right up. All right, welcome back, everyone. We will now take a look at a possible solution to this problem. So right off the bat, we have a problem asking us to reconcile the contents of two tables to check whether values in one table exist in the other. So immediately, you should think, I have to join these tables. And specifically, we are trying to reconcile the ingredient values from each table, so we should probably join using the ingredient columns. And finally, we need to decide what type of join we should use. Should it be an inner join or a left join? Well, what's our ultimate goal here? We need our final output to include recipes where all the ingredients match what's in the kitchen, and exclude recipes with ingredients that don't match. That kind of sounds like an inner join, keeping the records that match and discarding the records that don't. However, our situation is a little more complicated than that, and unfortunately, a simple inner join will not suffice. Let's see what would happen if we used an inner join. As you can see, we get all of the omelet and quiche recipe rows that we need for our final output, but we also get some rows for the chocolate chip cookie recipe. And that's because, while we don't have all required ingredients to make cookies, we do have some of the ingredients. So instead of excluding the entire cookie recipe like we want, a simple inner join will just include an incomplete cookie recipe. So it looks like an inner join is not what we need right now. Let's go ahead and try a left join and just see where that gets us. All right, this represents a clear improvement over the previous query. While it might not look like it at first glance, since now the output includes more cookie recipe rows than before, we are now actually closer to our goal, and that is because we now have something that differentiates the cookie recipe, which we want to exclude, from the other recipes, which we want to keep. Namely, the cookie recipe occasionally has nulls in this kitchen ingredient column, while the other recipes never do. The next question is, how can we use these nulls to filter out all cookie recipe rows, even the rows that don't have nulls in them? It's clear that we can't purely look at individual rows. Just because one ingredient, and therefore one row, matches the list of kitchen ingredients, that doesn't mean the entire recipe matches. We need to look at the recipe as a whole, or put another way, the recipe in aggregate. If that isn't enough of a hint, we need to use aggregation of some kind. But what can we aggregate? We have categorical data here, the names of ingredients, so we can't use a sum or other such numeric formula. But we can use a count. So let's try that. Let's aggregate at the recipe grain using the count function and see what we get. Now this is very interesting. This has revealed another useful differentiator between the cookie recipe and the other two recipes. For the recipes where all of their ingredients match the kitchen ingredient list, the recipe ingredient count and the kitchen ingredient count are the same. But for the cookie recipe, because there are nulls in the kitchen ingredient column and because the count function in SQL ignores nulls, the recipe and kitchen ingredient counts are different. And we can use this fact to filter out the chocolate chip cookies recipe. Just need to throw in a having clause, and voila, we have successfully filtered down to just the two recipes, quiche and omelette, for which our kitchen has all necessary ingredients. Except we're not quite done. Our home cook doesn't just want the names of the recipes they can cook, they want the full ingredient lists as well. So we need one extra step here to pull back in the full contents of the recipe table for these two recipes. There are actually two ways you can do this, and I'll briefly show you both of them. Option one, right here, is just a slight extension of the query we had in the previous step. We basically just wrap that existing query in a common table expression, or CTE, and then join it to the original recipe table on the recipe column. And as you can see, that works. It returns our expected results as hoped. Option number two, right here, requires us to modify our previous query a little bit. If instead of standard aggregation using group by, we instead calculate the ingredient counts as window functions, we can keep the grain of our dataset at the recipe ingredient grain, thereby allowing us to skip the join back to the original recipe table. We still need the common table expression in order for us to filter on the output of our window function counts right here, but otherwise I personally think this version of the query is slightly simpler and more elegant than the traditional aggregation strategy. As an aside, I only need this common table expression here because I am using Postgres, a database that has not yet implemented the qualify keyword. Qualify is a relatively recent arrival in the SQL language space, but it already has support in several major database systems. And basically, qualify is to window functions what having is to aggregations. It allows you to filter on the results of a window function in the same query without using a CTE or subquery. If Postgres supported qualify, then our solution could be even shorter and look something like this. But for now, the classic strategy of sequestering the window functions in a CTE and then filtering on them in a separate query works just fine. And that's it for this video. Thank you all for watching. If you have any further questions about this problem, or if you think of a different approach to the solution that I may not have considered, please let me know in the comments, and be sure to subscribe for more SQL query writing content in the future. Until next time, happy querying.